Yeah, good afternoon, class. This is Daddy Cause or Cosmas Dollar, your chemistry teacher. We'll be continuing from our our discussion about salt. So here this afternoon we'll be talking about solubility rule. You know, the rule that you can use to predict whether a particular salt will dissolve in water or will not dissolve in water. You know, you need this rule. Very, very important. When you understand this rule, even by closing your eyes, if you see any compound in your dream, you know that that compound can dissolve or will not dissolve just by this simple solubility rule. It is your power as a chemistry student to understand the solubility rule because it's going to help you in a lot of ways. For example, you need to understand solubility rule for you to know the method that is appropriate to prepare a particular salt. That tells you the solubility, the importance of that rule. If you don't know if a salt is soluble or not, you will not be able to know what method will you use to prepare it. Then, even recovering a salt from solution, the knowledge of this solubility rule will also help you very, very well. Now let us start. What is this rule all about? For number one, all sodium, potassium, and ammonium salts are soluble in water. You can see, we call them sparse salts. Sodium, potassium, and ammonium salts. All of them are soluble in water. No exception. No exception. So all sparse salts are soluble. Any salt that contains sodium, that contains potassium or ammonium, that salt will be soluble. So if you see Na inside the salt, that salt is soluble. Or if they tell you the name of a salt and there is sodium inside, that salt will be soluble. So any salt that contains sodium, potassium, or ammonium, we call them sparse salt. Though it's just my own way of mnemonizing the thing to make you understand it very well. I just call them sparse salts. So all sparse salts are soluble. All sparse salts are soluble. Take note of that. Very, very important. Now the second one is the triazonitrate 5 salt. Please, that VI is supposed to be V. Is triazonitrate 5 salt. So all salt that contains NO3, all of them are soluble. All salt that contains NO3, all of them are soluble. All nitrate salts are soluble. Whatever might be at the back, copper, gold, whatever. Once the salt contains NO3, the salt will be soluble. All nitrate salts are soluble, and there is no exception. No exception. All of them are soluble. I hope that's clear. Now for number 3 now, that's acetate salt. Acetate. This acetate. All acetate salts. Sorry about that. All acetate salts are soluble. All of them. So I'm in number 3 now. All acetate salts are soluble. No exception. Lead acetate, silver acetate, sodium acetate, potassium acetate, magnesium acetate. Once the salt is an acetate salt, the salt will be soluble. You are not familiar with acetate salt. They are organic chemistry salts. When you get there, you will understand. So all of them are also soluble. There's no exception. They dissolve in water without any exceptions. So we have seen 3 types of salts that whenever you see them in your dream or in real life, once they wake you up, okay, so salt is soluble or not, you already know that this salt is soluble. Number 1, sparse salt, that is sodium, potassium, ammonium salt. Number 2, nitrate salt. All salt that contains NO3, they are soluble. Then number 3, acetate salt. Number 3, acetate salt. So I hope you understand that now. Now let's now move to some other salts that not all of them are soluble, but most of them are soluble. Number 4, that's chloride salt. Most chloride salts are soluble. Don't let me say all because there are exceptions. But when you see a chloride salt, first of all, assume they are soluble because most of them will be soluble, except the chloride salt contains lead or contains silver. So when you see chloride salt, automatically assumed it will be soluble until you check it and you see Pb at the back. So if the salt is lead to chloride, then the salt will not be soluble. And of course, if you heat the water very well and the water is very hot, the salt can dissolve. That lead to chloride is soluble in hot water, but if the water becomes cold, then it will no longer dissolve again, so it will precipitate out. You don't even know of precipitate. We have done that before. So that is about chloride. Lead chloride is soluble only in hot water. Then silver chloride is not soluble at all. So of the two chloride salts that are insoluble, lead 2 chloride is insoluble and silver chloride is insoluble. But take note, lead 2 chloride can dissolve when the water becomes hot. Apart from these two compounds, for your level, assume that all the other compounds of chlorine, that is all compound that contain Cl, assume they will be soluble. It's not hard, isn't it? All sparse salt are soluble, all nitrate salt are soluble, all acetate salt are soluble. Now, most chloride salts are soluble with the exception of PbCl2 and AgCl. So when you say chloride salt, first of all, assume it will be soluble, but check the metal at the back of the chlorine. If the metal is lead, then it will not be soluble. If the metal is silver, it will not be soluble. So those two chloride salts are the insoluble chloride salts that we have for your level. There are some advanced chloride salts that are insoluble, but you don't need to bother your brain about that for now. When your brain becomes bigger and you become more matured, then I'll be exposing you to those chlorides. Now, sulfate salt. So we are number 5 now. Sulfate salt, you can see tetraoxosulfate 6 salts. Most sulfate salts are also soluble. It's just like chloride. Most sulfate salts are also soluble, but with few exceptions that you are supposed to know. Number 1, calcium sulfate. This calcium sulfate is, it's not that it's not soluble, it's just sparingly soluble. That is, very only minute part will dissolve in water. It's just like throwing what do you call it now? Let me use chalk for example. Throwing chalk inside water, a bunch of chalk. So only few of it will get wet in the beginning. The bag will get wet. So, but as time goes on, the thing will get. But normal, that's just sparingly. But calcium sulfate is just like that. A little amount will dissolve, but you still see the chunk of the salt, plenty of the salt undissolved. So we call that sparingly. Sparingly means very, very little. Very, very little. So calcium sulfate dissolves sparingly in water, but not very soluble in water. Take note, this calcium sulfate salt is a very important salt to us in chemistry because it's the one that causes permanent hardness of water. You know that some water can be hard. You have not seen hard water before. When we get there, you will see that some water can be hard. So when calcium sulfate inside the water will be hard because part of it can enter inside the water and dissolve in the water. So it's sparingly soluble. Now let's come to lead sulfate. If the sulfate salt contains lead, the salt will not dissolve. Did you observe that for chloride and for sulfate, whenever they contain lead, they don't normally dissolve. You can see that lead 2 chloride doesn't dissolve, lead 2 sulfate also doesn't dissolve. So whenever chloride salt or sulfate salt contains lead, the salt doesn't dissolve in water. So there are exceptions. Now finally, barium sulfate. Barium sulfate does not dissolve in water also. So we have 3 exceptions to the solubility of sulfate ion, of a sulfate salt. Calcium sulfate, that one is sparingly soluble. Lead sulfate, that one is insoluble at all, alongside barium sulfate. So I hope you understand it now very, very well. So what you just need to note is that all chloride, most chloride and most sulfate are soluble, except you see lead. Once you see lead at the back of a sulfate or chloride salt, is insoluble. Now for chloride, silver chloride is insoluble. Is that okay? Now for sulfate, calcium sulfate is insoluble, lead sulfate is insoluble, then barium sulfate is insoluble. There's something that I want you to also know. There's one sulfate salt that doesn't dissolve also. The sulfate salt is called silver sulfate. Just like we have silver chloride that is not soluble, silver sulfate is also not soluble. Ag2SO4. That silver sulfate is also not soluble. It's not soluble also. So you see, silver chloride is not soluble, silver sulfate is not soluble, lead chloride is not soluble, lead sulfate is not soluble. Take note of that. So the only differences in the solubility from sulfate and chloride that are exception now is calcium sulfate. Calcium chloride is soluble, but calcium sulfate is sparingly soluble. So once you see lead or you see silver at the back of a chloride salt or at the back of a sulfate salt, that compound will not dissolve in water. It's an insoluble compound. Please don't forget that. If you need to memorize, but I'll be able to arrange it such a way that it will be easier for you to comprehend very, very well. So we are done with the hardest part, which is chloride and sulfate that have exceptions. The remaining ones that we'll be treating now, they are insoluble. They can't dissolve at all. They won't dissolve. They will not dissolve at all, except they are spar salts, except they contain sodium, potassium, and ammonium. And let us start. The first of them that are insoluble, carbonate. All carbonate salts, my brother, all carbonate salts are insoluble in water. All carbonate salt, except it's a sparse salt. That is, except it's sodium carbonate, potassium carbonate, or ammonium carbonate, except the salt is a sparse salt. All carbonate salts are insoluble. Only the sparse salt. Is that not easy? What the salt is a carbonate salt. This one cannot dissolve, jare, except you now see that there's sodium there. All sodium salts are soluble, so you now get that. So all carbonate salts are insoluble, except those salts are spar salts. So you get that like that. The same rule that applies to carbonate also applies to sulfate. Look at it. All sulfate salts are also insoluble. And it pays us because there is a sulfate salt inside our teeth. Calcium phosphate rather. Assuming phosphate salt are soluble, you will not be able to drink water. All your teeth will just dissolve away, and you not like that because of the Sunday chicken I normally eat. So that's why it is good that some salts are not soluble. Imagine if calcium carbonate is soluble. You know that calcium carbonate is limestone that we use for building house. Imagine if it's soluble in water. Anytime there is rain, your house will just dissolve as if it's a cube of sugar, and you will not like that, isn't it? So you can see the importance of some salt being insoluble. Calcium phosphate in our teeth is insoluble, so it's very good that it remains there. Also limestone, calcium carbonate. So all phosphate salts, all tetraoxophosphate 5 salts are insoluble except it's a spar salt. Except it's a spar salt. Except it's a spar salt. So all tetraoxophosphate 5 salts are insoluble except it's a spar salt. Take note of that. It will be very good for your health when you remember it. So finally, this number 8, they are not actually okay. They are not all salts. Actually, oxide is not a salt. Oxide is a base. If it's a uh, for what do you call it now? For metals, the oxides of metals are bases. Also hydroxides, they are also bases. So, but I just want you to know that they are also not soluble. They are also not soluble except they are spar salts. Except they are spar salts. So all sulfide, oxide of metals, hydroxides also, they are insoluble compounds except they are sparse salts. The only exception that I want you to note about hydroxide is that hydroxide is sparingly soluble. Calcium hydroxide, not all the hydroxide though. Calcium hydroxide, calcium hydroxide, they are insoluble. Insoluble. They are sparingly soluble, but the rest are not soluble. So sulfide salt, oxide salts of metals, hydroxide compounds, they are insoluble except they are spar compound. So I hope you understand that and you get it very well. So that is the solubility rule. Solubility rule. That's not hard. Make sure that you learn it, you know it. When you know it, it's very good for your health. You'll be very healthy. You'll not be visiting health bay when you understand all these things during exam. So let's see some examples that will make our life to be okay. Let's see this checkpoint 5. I said, should use solubility rule to determine whether the following salts are soluble or not soluble. Now, see the first one there, KNO3. See KNO3. Will it be soluble or not? Of course, it will be soluble in 2 parts. It contains potassium. All spar salts are soluble, isn't it? Then apart from that, it also contains nitrate, NO3. So since all nitrate salts are soluble, it will also be soluble. So there are two ways by which this salt can become soluble. That KNO3 is a spar salt. So it's also a nitrate salt. So it's a very soluble salt. Just note that when it contains one particular radical that can dissolve, it will dissolve altogether. Now let's see number 2 now. Number 2 is calcium chloride. Calcium chloride. Now see calcium chloride. If you want to check if it's soluble or not, you go under calcium, under chloride rather, under chloride. You see that all chloride salts are soluble with the exception of lead 2 chloride and silver chloride. Now I told you that whenever you see a chloride salt, first of all assume they are soluble until you now check the back. So if you now check the back of that salt and the metal that is there is not lead and it's not silver, then you know that salt is soluble, because those lead 2 chloride and silver chloride, they are the exception to the salt solubility rule of the salt. So since calcium is not silver and is not lead, so its chloride is very soluble. So we have seen that calcium chloride is soluble. Calcium chloride is soluble. Now let's see number 3. Number 3 is copper trioxocarbonate 4. copper 2, that's CuCO3, copper 2 trioxocarbonate 4. Now, will it be soluble or not? You check this anion. Is a carbonate salt. Is a carbonate salt. Now you ask yourself this question: are carbonate salts soluble? If you don't know, you go and visit the solubility rule. If you check the solubility rule, all carbonate salts are insoluble except their sparse salts. Except their sparse salts. So, and copper is not sodium, it's not potassium, it's not ammonium, so it's not a spar compound. So copper carbonate is insoluble, and in fact it's very, very insoluble. So it's an insoluble compound. It's a green powder. It's not soluble. Let me give you one hint. When you enter laboratory and you see any chemical that looks like a powder, that compound will not be soluble. Most times they will not be soluble. But the one that looks like sugar, that looks like salt, like common salt, the one that is crystalline, they are always soluble. It's just a trick, It's good for you to know that. Now, let's see silver chloride. Now, I've told you already that whenever you see chloride, first of all, assume the compound will be soluble, except you now check the back, whether there's no silver at the back or there's no lead at the back. So if silver is at the back, then it will not be soluble. Or if lead is at the back, it's not soluble. So this one now is a silver chloride. So the chloride of silver is insoluble. Is insoluble. Is insoluble. So that is why we know that it's not soluble. So you can do the rest. Number 5 is ammonium chloride. Do you think it will be soluble? Why will it be soluble? After that, what you assume about chloride. And of course, ammonium chloride, ammonium salt. You know what happened to ammonium salt. Are they always soluble or not? Now see PbSO4. Number 6 is PbSO4. Are they soluble? Is lead sulfate soluble? First of all, check all sulfates. Assume that all sulfates are soluble, except you now see some metals at the back that are not good for their health. You know those metals. I won't tell you the answer. Now zinc carbonate, you've seen that is a carbonate salt. Now what's happened to solubility of carbonate salt? Are all carbonate soluble or they are insoluble? Go and check the solubility rule, then you will know it. Now let's see number 8, aluminium phosphate. That's aluminium tetraoxophosphate 5. Now go and check. It is a phosphate salt. So are all phosphate salts soluble? If not, are they insoluble? So you go and check. Number 9 is a sulfate salt. Now check. Sulfate salt, are they all soluble? Are they not all soluble? You check sulfate salts. Are they all soluble or they are not all soluble? So if they are not soluble, what are the exception? Is calcium part of the exception? So you check by yourself. Then sodium carbonate is a carbonate salt. Now, so you go and check under carbonate. Are carbonates are soluble, or it has sodium at the back? Would that one make it to dissolve or not? So that's how you check and you confirm whether salts are soluble or not. So let me see your answers to this. If just go through it, anyone you don't understand whether it's soluble or not, let me know. You can voice note me on WhatsApp, so I will answer your question speedily and readily. So that is that about solubility rule. So by now, I think and I know that you will be able to know if any salt is soluble or not soluble. That's how you become chemist. That's how you can have confidence whenever you are working in the laboratory that okay, I'm now a chemist. So that is that about that. Now let's go to preparation of salt. How do we prepare salt? How do we prepare salt? How are salts prepared? You can see from this place now, there are 5 different ways by which salt can be prepared. You know all those formulas that I gave to you: acid plus base, salt and water, acid plus metal, salt and nitrogen, acid plus carbonate, salt, water and carbon dioxide. Don't forget that, you remember that. acid plus triazosulfate 4 salts, salt water and sulfur 4 oxide, acid plus metallic sulfide, salt water and hydrogen sulfide. You see that all those 5 reactions, they are always producing salt as one of the products. So you can use any of those methods to prepare salt depending on the kind of salt that you want to prepare. You must pay a very good attention to that. So with these 5 basic reactions, you can prepare a salt. But let's just break it down one by one now. How do you prepare salt? Which method is the best for preparing a particular salt? You cannot just say this method that I want to use to prepare salt. No, you have to understand the chemistry of the salt. You have to understand, okay, what is it about this salt? Then which method will best be used to prepare the salt? There are 2 factors you will consider before you prepare a salt, and the most important factor is whether the salt will be soluble in water or not. Very, very important. There are methods that you use to prepare soluble salts which cannot be used to prepare insoluble salts, and there's a particular general method for preparing insoluble salt. Take note of that. Now the second factor, which is stability to heat, that is whether when you heat them they will not decompose or they will decompose. That's stability to heat. Now this method, this factor actually can give information about how to recover the salt after you have prepared it, because most of these salts, when you prepare them, because they are soluble, if they are soluble now, they will remain inside the solution dissolved. So you now want to separate the salt from solution. You know how to separate salt from water now. You can use evaporation method or you can use crystallization. You know that before. Now the method you will now use to recover it will be based on whether the salt is stable to heat or will decompose when you heat it. Now to prepare the salt itself, the factor you consider is the solubility of that salt in water. Now this salt I want to prepare, will it dissolve in water or it's not going to dissolve in water? You want to ask yourself that question. That is the importance of the solubility rule that we just finished learning. The way you prepare sodium chloride cannot be the way you are going to prepare copper 2 trioxocarbonate 4 salt, because one is soluble, one is insoluble. So solubility of the salt in water is a very important factor for you to know which method will you use to prepare a salt. Now the one I want to discuss with you now is the method for preparing a salt when the salt is soluble in water. To prepare a salt when the salt is soluble in water. Number 1 method, once you know that this salt is soluble in water, then you can use this first method, action of acid on metal. Remember in this introduction to preparation, acid can react with metal to give you salt. This number 2, acid can react with metal to give you salt. You call that displacement reaction. I will show you now. So you can react acid with metal to give you salt. So if the metal is a very reactive metal, if you dissolve metal inside the acid will displace hydrogen and form a salt. Now see what happens here now. The zinc will send this hydrogen away, right? So it will now give you zinc chloride. That's not bad, isn't it? Then the hydrogen will be displaced. So you call this a displacement reaction. A displacement reaction. It happens because zinc is more reactive than hydrogen. So it sends hydrogen away. It's just normal. Because principal is more reactive than a teacher. Principal is higher than teacher. So principal can ask teacher to go. If the teacher is fumbling too much, can sack teacher. but teacher cannot ask principal to go. It doesn't work that way. So because zinc is more reactive than hydrogen, it can displace hydrogen from that acid, so you form a salt in the process. So that's the first method, action of acid on metals. Let me just give you some brief explanation on it. You will need it as an experimental student. If you dissolve if you dissolve zinc or any metal whatsoever that is more reactive than hydrogen, if you put it inside acid, you will be putting it inside the acid. Once you drop it in the acid, hydrogen gas will be coming out with speed, with bubbles. You call that effervescence. Some of you have forgotten, I taught you that in the laboratory. Effervescence, you call that effervescence. So hydrogen will be coming out from the water in bubbles. We call it effervescence. So effervescence will occur. That shows you that the reaction is taking place already. So hydrogen will be leaving the acid. So what we are going to be getting will be zinc chloride. So you keep adding the zinc or the metal, keep adding the metal will be dissolving. Continue to add the metal, it will be dissolving until either the effervescence no longer occur, that is hydrogen no longer comes out, or the metal you are adding no longer dissolve. So it is that time that you are sure that okay, the reaction is complete. So and because you will have added excess zinc that would not dissolve, you just filter off the excess zinc. So the solution you are having now is a solution of zinc chloride. This zinc chloride, because all the hydrogen have already escaped away. So that's how you prepare zinc chloride. If you need it to come out in a solid form, you can evaporate the solution to dryness, or you can crystallize it. So that's the first method, action of acid on metal. Another method is action of acid against alkali. You remember, you call that reaction a neutralization reaction. You remember that? Sorry about my handwriting. I want to really learn how to write very well. So we call that a neutralization reaction. When an acid reacts with an alkali, you call that a neutralization reaction. Are we together? Now, most times when you perform this reaction, you don't just mix the acid with a base, you titrate. When you get to school, that's what we're supposed to do in week 4 before your test. We'll titrate an acid with a base. I'll teach you how to do titration. You put the acid inside the burette. You know burette already. Then you put the base in a conical flask. You add a suitable indicator. Then you begin to release the acid small into the base of the conical flask. Then you begin to do it. Of course, the indicator, what they do is to change color whenever the pH is also changing. You remember that indicators are organic dyes that show color changes according to the pH of the solution. You get that stuff like that. So you shake it, you swirl it. Then once the indicator changes color, then you stop titrating. Then that's how you react an acid with a base, to be able to know a particular volume of the acid that will completely react with a base. So that is how you prepare a salt by the action of neutralization reaction. Now this reaction is neutralization, it's not displacement, because nothing is being displaced here, just that a salt is being formed. I've already told you how to do that. Potassium will come here, replace hydrogen. Hydrogen will also come here, replace potassium. So what you have there will now be K connecting with NO3. So that's why you have KNO3 here. Then this H will connect with the remaining OH. When H comes to OH, what are you having? You're having H2O. H2O. That's how we have this H2O. So it's just a neutralization reaction that is very, very important for your health. And I hope you understand that very, very well. That's the second method by which you can form a salt. Number one method is the action of acid on metal. Number two method is action of alkali on acid. Number three method of preparing a soluble salt is by reacting dilute acid with an insoluble base. Now, take note of that. Most bases are insoluble. I told you before that most of those bases are insoluble. Those that can dissolve among them, we call them alkali. Now, the same method you are going to use when you are adding metal to an acid is the same method you are going to use when you are adding insoluble base to an acid. Now, let's take an example here. Copper oxide is a base in this place. You know that oxide of metals are bases. So this is a base. Now, because it's insoluble, you cannot titrate it. It doesn't make sense to titrate it with an acid. What you do is you get this acid like this, put it on a Bunsen burner, put the acid there. Is that okay? When you put the acid there on the Bunsen burner, use spatula, that one that looks like spoon. Use spatula to collect the CuO, the powder of CuO. You know, it's like powder. So take your spatula, pick part of it, add it into this place. When you add it, you will see that reaction is taking place because the color of the solution will be changing, because this compound has color. So as you add it, it will be turning blue. But begin to stir it as you're adding it. Stir it, keep adding, stir it, keep adding it, continue stirring, keep adding it, continue stirring, keep adding it, continue stirring, until you are going to add one more spatula and the thing will not dissolve. So when you add one more spatula and what you added there doesn't dissolve, it shows that the reaction is already complete, just like what we did with acid and metal. So you have to now filter off the undissolved copper oxide so that the solution you are having now, that filtrate that you are having, is the solution of copper 2 chloride inside water. So if you now want to get it in a solid form, you can do crystallization. You know how to do crystallization now. You know it. Don't say you don't know it. Okay, you know how to do it. Just allow the solution to cool down. When it cools down, crystals of the salt will begin to form. You now remember. So if crystal is not forming very well, you know what to do. You scratch the inside of the funnel of the vessel. If you scratch the inside, it's the crystal will form. Or you can crystal seed. Remember crystal seeding. Add a little bit of the crystal of that sort, tie it to a rope, put it inside the solution. The crystal will be becoming bigger. Remember the video? That's crystal seeding. So that's how you prepare a salt from an insoluble base. So I hope you understand now. Don't forget that you can use action of acid on metal. You can use action of alkali on acid. Then number three, you can use action of dilute acid on insoluble base. In this case, you have to warm the acid because of so that the reaction can be fast. You need to warm the acid. Now, the last one is action of dilute acid on trioxocarbonate phosphate. It's almost like the action of dilute acid on insoluble base, because most of the trioxocarbonate phosphate also they are insoluble. Remember the solubility rule. All carbonate are insoluble except they are sparse salt. So most of the carbonates you will be encountering in your lifetime will be insoluble carbonate. So but you can still use it to prepare salts, just like insoluble base and acid. So you just put acid on. In this case, you don't even need to heat the acid. If you put the carbonate salt into the acid, a miracle will happen. Let me show you the miracle. This is a miracle. We have an acid, right? This is the acid, H2SO4. We have an acid like that, H2SO4. Now, a carbonate salt is this. So what you just do is add the carbonate salt drop by drop. Use spoon, spatula to pick the carbonate salt. Put it into the H2SO4. Now you see that CO2 is formed. CO2 is a gas. So the CO2 will come out with effervescence. So you are going to observe bubbles. You are going to observe bubbles of gas coming out from that solution. So in this case also you are going to be experiencing effervescence in this place. Now, when the effervescence stops, that means the reaction has also stopped. So two ways. Number one, when the effervescence stops, you know that the reaction has stopped. Or when the carbonate salt that you are adding no longer dissolved, then you also know that the reaction has stopped. If I've added excess carbonate, you know what to do in real life. You filter off the excess carbonate and your life will not remain the same again. So that is how you do that reaction of carbonate on acid. Reaction of carbonate on acid. Now, in some special cases where the carbonates are soluble, like sodium carbonate, potassium carbonate, or ammonium carbonate, you don't need to go through that method. You don't need it. Since they are soluble, dissolve them in water and treat them like an acid-base reaction. So since they are soluble, put them in a conical flask, put the acid in a burette, then titrate the acid with the solution of the carbonate salts. So in that sense, you are going to be doing titration. So you still be seeing effervescence, but in this case you are going to use indicator. When you use indicator, the indicator will change color. So when the color changes, it tells you that the reaction is complete. So those are the 4 methods that we use for preparing a soluble salt. Can you remind me the first method? Number 1, action of metals on acid. Number 2, action of alkali on acid. Number 3, action of what? Action of acid on a insoluble base. Then action of acid on trioxocarbonate for salts. Those are the method for preparing insoluble for preparing a soluble salt. Now, I've already explained this to you in the course of my explanation. How do you recover those salts from solution when the salts have already dissolved? Because they are soluble salts, they will have dissolved already in the solution. So how do you recover them from solution? There are 2 methods and the method you are going to use depends on the melting point of the salt, that is how stable the salt is when you heat it. So chloride salt generally, all chloride salt generally are soluble to heat, are stable to heat. They don't easily decompose when you heat them. All of them, apart from ammonium chloride, the one that sublimes, and that one is not stable to heat. Some other chloride like iron 3 chloride also. So both of them are not stable. So you cannot evaporate the solution to dryness. They will get destroyed. They will get decomposed. So what we're just going to do is, if they will get decomposed, you will not evaporate the solution to dryness. You will crystallize. You will take pain to crystallize the salt. I've already told you how to crystallize. So salts that get decomposed, when you heat them, what happens? You don't evaporate them to dryness, you crystallize them. Example of those salts are sulfate salts. Sulfate salts, they don't have high melting point, so they get decomposed. Nitrate salt also, so you crystallize them. And carbonate salt, when you eat carbonate salt, yeah, they would decompose very easily. So you crystallize them instead of evaporating their life to dryness. So that is how you recover new. I didn't say prepare. You recover soluble salt from solution. Before you can recover, you must already prepare. You must have prepared already, either by using acid on base, acid on metals, acid on insoluble carbonate, then acid and alkali. You must first of all do that one first. You must have gotten the salt before you can talk about recovering the salt from solution. I hope you understand that. It will be good for your health if you understand it. So that's that about that. That's how you recover salt from solution. So by now you can go to the laboratory and prepare any salt of your choice. Let's Before the class we end, let's talk about how to prepare insoluble salts. Actually, there are two major methods of preparing insoluble salt. Number one is by direct combination. You already familiar with direct combination under acid. You only use this for a binary salt, that is salt that contains two elements. The word binary, you know the word binary from mathematics now, 0 and 1, two numbers. So in chemistry we also have binary salt that contains two elements. So when a salt contains two elements, you can prepare that salt by combining the elements directly. That is what we call direct combination. For example, iron sulfide. You know that iron sulfide is an insoluble salt, but that iron sulfide is actually a binary salt. So you can heat iron with sulfur and then you get iron 2 sulfide. You can heat iron with sulfur, then you get iron 2 sulfide. You know that a reaction is occurring because the color of iron is actually is gray, is grayish in color, like ashes color, while the color of sulfur is yellow. So if you heat both of them together, the color will turn black. That's FES is having a black color. So that is the observation you are going to use to see that a reaction is actually occurring in this place. So that should be very clear enough. Another example is Fe3, FeCl3. Iron 3 chloride is a soluble salt, but because it's a binary salt, you can also prepare it with direct combination. So you get that now. The most common and the most important method that you cannot do without in your life as a chemistry student is double decomposition. You know that double decomposition, another word for it is precipitation. This is the most common method for preparing insoluble salt. Whether the salt is a binary salt is a trinary salt or the one that has four elements once the salt is an insoluble salt, you can precipitate them in a chemical reaction. I already taught you double decomposition under bases. It's still the same thing, and you should be able to write the ionic equation of a double decomposition reaction. We have also done ionic equation. Please, I want your head to be boiling with chemistry so that anywhere you go, you can understand the chemistry of what is happening in your environment. Is that okay? So when a salt is an insoluble salt, you can prepare them by double decomposition. You know how we prepare salt by double decomposition. You know how we do that. You mix two aqueous solutions together. One of the solution will contain the cation or the metal part, if you like. The second solution will contain the anion or the radical part. So when you mix them together, because one of the products will be insoluble, a precipitate will be formed. So that precipitate that is forming is the insoluble product that you want to prepare. For example, in the case of silver chloride, where you mix AgNO3, see, you want to prepare silver chloride, isn't it? See, let's see together. You want to prepare sodium chloride, silver chloride. You need silver from one soluble salt and chloride from another soluble salt. So when you mix this and this together, automatically silver will meet chlorine, and then because silver chloride is an insoluble salt, there will be precipitation. You can see that I put solid here now. Solid means that a precipitate has been formed. When you see solid, when you see physical state solid, if you mix aqueous and aqueous together, if you mix aqueous and aqueous together, this aqueous, and you are getting solid, that reaction is called precipitation or double decomposition, because that compound that has solid we come out as a precipitate. Sometimes it can be white precipitate. In the case of silver chloride, it can be yellow precipitate, it can be green precipitate. You have seen different type of precipitate before. You saw pale blue gelatinous precipitate before you went home. You saw dirty green, you know those in greenhouse, how dirty they are. You also saw reddish brown gelatinous precipitates. So all those ones, they are double decomposition reactions. So that is how you do double decomposition. You react two aqueous solutions together, and then you get a precipitate. You get a solid form. So you call that a precipitate. A precipitate. A precipitate. So this is the net ionic equation. I don't need to start teaching you that one. We have done. I've taught you how to determine the net ionic equation of a double decomposition reaction. Now another example is barium chloride and sodium carbonate. It's also aqueous. That is, both of them are soluble in water, but it now give you a barium carbonate salt. You know that all carbonate salt are insoluble apart from sparse salt. That's what makes this one to be soluble. Now, when it now reacted with another compound, it forms barium carbonate, which is insoluble. So this insoluble compound is the precipitate. So that is precipitation reaction. That's precipitation reaction. So let's see our checkpoint 5 now. I said we should state 3 methods of preparing salts, giving one example in each case of a salt so prepared. You already know, I've already told you that, so just if you have forgotten, just rewind this video and your life will not remain the same again. Now number 2 is, what type of salt is each of the following? What type of salt is each of the following? And is it an acid salt? Is it a basic salt? Is it a normal salt? Is it a complex salt? Or is it a double salt? We have done this one in our last class, but it's good that you always remember. The first one is sodium dihydrogen tetraoxophosphate 5. Now you should know what type of salt is it. I've already given you hint. Whenever hydrogen is inside the name of a compound, or hydrogen is inside the middle of a chemical formula, what type of salt will it be? Now see this one. This one is very strong. It's very strong. The name is called lead acetate. You remember acetate ion? CH3CO is called acetate ion or ethanoate. It's called acetate, or in the IUPAC format we call it ethanoate. Ethanoate. So this is lead 2 ethanoate, or lead 2 acetate. Now you want to know whether it is soluble, whether it is of course you know that it's a soluble salt. All acetate salts are soluble. You want to know whether it's an acid salt, a basic salt, a normal salt, or whatever kind of salt you think it may be. Remember that when all the ionizable hydrogen of an acid has been replaced. That's when you have a normal salt. When all the ionizable, all the hydrogen that can be ionized, when everything has been replaced, that is when you say you have a what? You have a normal salt. Now take note of this one. The acid that forms this compound must have been this acid. I don't know if you have encountered this acid before in your lifetime. Of course you do. The name is ethanoic acid or acetic acid. So you know why they call it acetate now? Because it's from acetic acid. Or they call it ethanoic acid. So that's why it forms ethanoate. When you get organic chemistry, we'll be treating that. But what I just want you to know is that this particular acid that forms the salt, what is the basicity of the acid? Is it 4 or 1? Definitely 1, right? Because out of these 4 hydrogen, only the one here is ionizable. We've already said that, so we don't need to start arguing now. You know that these 3 hydrogen in the middle are not ionizable because they are joined to carbon. Any hydrogen that is joined to carbon with a single bond is not an ionizable hydrogen. So only that hydrogen that is in front of oxygen, this COOH hydrogen, is replaceable. So, and got so good, it has been replaced by lead. So what do you think about that? So let me know what you think about it. Voice note me on WhatsApp. Should it be an acid salt still, or will it be a normal salt now? Or is your village people even telling you that it's a complex salt? So let's know. Let me know how far you are in that. Now see this salt C. Let's see this salt C. You remember when you have a sulfate ion, you have aluminum ion, then you have a potassium ion. Remember what type of salt is that? The salt that produce 3 different type of ions in solution. You know what type of salt that we call that, and see it has water crystallization. So I don't need to tell you the answer, but you know we will call this type of salt alums. But what type of salt are alums? What type of salt are alums? What type of salt are alums? What type of salts are alums? So see this one now. Checkpoint 6. How do we prepare? What method do we use to prepare this kind of salts? Let me do 1 or 2 things for you there. Then I want to see what you think about others. The first salt to prepare is PbSO4. PbSO4, let us see. Ask yourself, what method will I use to prepare this salt? What method? PbSO4, is it a soluble salt or an insoluble salt? If you check your solubility rule, all sulfate salts are soluble apart from lead sulfate and some other and silver sulfate. So this PbSO4 is an insoluble salt. So definitely I will need a double decomposition method to prepare it, and you know how to do that. So if I'm starting with PbNO3, that means I already have something that will give me the Pb aspect of the PbSO4. If I'm starting with PbNO3, that means that this Pb now has already supplied what I need there. So I need SO4 more, and it must be a salt that is soluble. You know what else I can use? I can use H2SO4. I can use H2SO4 or any other soluble compounds. So they're not even asking us what other material we can use now, but they are saying what is the method. So of course, when preparing soluble salts, you know that the method is a double decomposition method, right? Now see another example that has been done for us there. KNO3 is a soluble salt. So our options are limited to acid on metals, acid on insoluble base, acid on carbonate salt. So we have limited something there. So if you are starting from KOH, of course KOH is an alkali. You know that I must use acid to also react with it to get a salt. And that method is called neutralization reaction. Neutralization reaction. Neutralization reaction. So that is that about that. Now let me see your idea about this order number 3. Number 4, number 3 is calcium chloride. What is your idea about calcium? What do you think about calcium chloride? What method will you use to solve it? This calcium chloride. This number 3. What method will you use to do it? Remember, calcium chloride, we are starting from a carbonate salt. Now, calcium chloride is a soluble salt or an insoluble salt. Ask from yourself whether soluble or insoluble. Now, but already they say we should start with a carbonate salt. So, is there something like action of acid on carbonate salts or whatever? This is an insoluble carbonate. Let me understand. Let me know whether you understand how to do it. Then, if you understand it, I want you to voice note me if you have the time, and give me the process. Will you titrate the carbonate salt with an acid, or you will add the carbonate salt into the acid and filter off the excess? Let me see the method that you think will work for calcium carbonate. You want to prepare calcium chloride from it. And which acid do you think you add to this to give you calcium chloride? Of course, you already see calcium aspect, so you need the chloride aspect. So which acid will give you that chloride? So I don't need to tell you all the answers so that you will not be spoon-fed. Now, let's see FeCl3. Of course, there are two ways. FeCl3 is a binary salt. You don't even know, or you've forgotten. You should know. So FeCl3 is a binary salt. You know what to do about it when you have a binary salt, or it's a soluble salt. You can also try your luck, but there's something you must understand there. If you react Fe, already Fe has given you this. Now you need a chloride salt. If you react Fe with HCl, you will not get FeCl3. You only get FeCl2. So I will explain that to you later more. So the compound will not go to FeCl3. It will go to the lower oxidation state of iron, which is 2. So it means that you cannot add acid to metal. Then which other method can you use? It's a binary salt. I've already given you one. Then what if? So I think you are left with just only one option. But think about that. So the last one is that you want to prepare copper sulfate, copper 2 tetrasulfate 6. You want to prepare copper sulfate, this salt, and you are starting with copper oxide. Ask yourself, copper sulfate, is it soluble or insoluble? If it is soluble, fine. This copper 2 oxide is a base. It's not an acid. It's not a salt. It's a base. So what method do you use to prepare a salt? Starting from a base. So you write the method there. So let me see your something. Do it in a note and snap it to me on WhatsApp. So I think we'll be ending the class here. For today. Then we'll continue by God's grace in our next class. God bless you real good. If you have any question, don't forget, let me know. You can voice note the question to me. Or you can chat me up on WhatsApp. God bless you.